Hello guys, in this class we will discuss maxima minima previous topic, and again we are using second derivative test, but right now the change is we are taking trigonometric functions. In last class we discussed polynomial functions. So according to trigonometric functions, when we use second derivative test for getting maxima and minima, so working rule is similar. First we have function, uh, and now first we get f dash x, second we put equals to 0 and solve for x, and getting the values of x. But right now these values are not numeric values, these are angles in case of trigonometry. So answers will be in terms of pi by 2, pi by 3, pi by 4, like this. So now we obtain second derivative and put these values for checking maximum minima in f dash x. So values just like pi by 2, pi by 3, like these values, we place it in f dash x and get the values. So whatever the values, f double dash of let us consider pi by 3, if it is negative then it shows local minima. When we get result as positive, then we get local, this is maxima, local maxima, and in case it is positive then it will be local minima, and in case of 0 you can't decide negative positive, then that is the point of inflection. And last one, maximum minimum values, then we put that value x equals to like pi by 3, we put in the function, given function. So this way we will use second derivative test for trigonometric functions. Right now we are taking the questions. So given function fx is sine 2x, and interval at which we will check this, that range is 0 to pi, and we are getting local maxima and local minima for this function. So according to second derivative test we will apply this. So first we will differentiate it, and on differentiation of sine 2x we get 2 cos 2x. Now we put it 0, 2 cos 2x equals to 0, and cos 2x is 0, means possible values are cos pi by 2 or cos 3 pi by 2. But when you equate this, so first you get 2x equals to pi by 2 or 2x equals to 3 pi by 2, but you want the value of x, so x will be pi by 4 and x is 3 pi by 4, which lie between this 0 to pi. So first is this and second is this. Now we will differentiate f dash x again, so we get minus 4 sine 2x. Now for checking maximum minima on these two values of x, so first we are taking case 1 when x is pi by 4. So put this value in this differentiation second derivative, so we get f double dash pi by 4 will be minus 4 sine 2 into pi by 4. So it is pi by 2, sine pi by 2 is 1, so minus 4 into sine pi by 2, it is 1, so minus 4 means negative, so it is negative. Then we get local maxima at pi by 4, and the maximum value will be f pi by 4. We put this point in a given function, so it will be sine 2x and sine 2 into pi by 4, so we get sine pi by 2, that is 1, so maximum value is 1. Now we have second value x equals to 3 pi by 4, and we check the similar manner. Case 2 when x is 3 pi by 4 and f double dash x is minus 4 sine 2x. So put this value in second derivative, that is 3 pi by 4 to minus 4 sine 2 into 3 pi by 4, so cancel out this, you get minus 4 sine 3 pi by 2, so it is in third quadrant, so it is minus 1, so on multiplying this we get positive 4. So f 3 pi by 4 is 4, you can say greater than 0 or you can say positive, so it shows local minima. At 3 pi by 4. So right now we will collect the value, minimum value. So it will be f 3 pi by 4, and we have function that is sine 2x, so that is sine 2 into 3 pi by 4, so it is sine 3 pi by 2, so that is minus 1. Now next question, find local maxima and local minima of the trigonometric function fx equals to sin x minus cos x when x vary 0 to pi by 2. So this is the restriction in which we want to collect local maxima and minima. We will apply second derivative test. So for this, first we differentiate it. So the differentiation of sin x is cos x and differentiation of cos x is minus sin x. So finally we get sin x plus cos x. So this is first derivative, f dash x equals to sin x plus cos x, and according to second derivative test we put it as 0, so we get sin x equals to minus cos x. So on taking cos x on left side, right now you get 10x is minus 1. So in second quadrant the value of 10x, that is 10 3 pi by 4, and in fourth quadrant it will be 10 7 pi by 4. So x will be 3 pi by 4 or 7 pi by 4. So right now you have these two values of x. So we will check maxima or minima on these two values. So first, these are the candidates. So on first candidate, case 1, we are taking okay. Now first we differentiate once again this f dash x, so we get cos x minus sin x. So this is the second derivative on which we put these values and check the local maxima and local minima. So right now you have two values, x is 3 pi by 4 or x is 7 pi by 4, and second derivative is cos x minus sin x. So first candidate, case 1, when x equals to 3 pi by 4. So put this value in second derivative, so it will be 3 pi by 4, it is cos 3 pi by 4 minus sin 3 pi by 4. So in second quadrant cos is negative and sin is positive. So you get negative value minus 2 by root 2, that is minus root 2. So it shows local maxima. So the maximum value of the function will be at this point, at this candidate. We put this value in the function. So function is sin x minus cos x. So sin 3 pi by 4 minus cos 3 pi by 4. So it is 1 over root 2, second quadrant sin will be positive, and minus cos is negative. So you get, this becomes positive. So you get 2 over root 2 and answer is root 2. So the maximum value at 3 pi by 4 is root 2. When x is 7 pi by 4 and second derivative is cos x minus sin x. So put this value, f double dash 7 pi by 4, that is cos 7 pi by 4 minus sin 7 pi by 4. So it is 2 pi minus pi by 4. So it is in fourth quadrant. So in fourth quadrant cos is positive and sine is negative. So this is 1 over root 2 and this is minus of minus is positive 1 over root 2. So it is root 2, that is positive. So if second derivative at second candidate is positive, that shows local minima. And the minimum value of the function at x equals to 7 pi by 4. So it will be f 7 pi by 4. We put it in the function, that is sine 7 pi by 4 minus cos 7 pi by 4. So in fourth quadrant sine will be negative and this is positive. So you get minus 1 over root 2 and minus 1 over root 2. So this becomes minus 2 over root 2. So it is minus root 2. So minimum value is this.